Hello, my name is Felix Geisendoerfer, and I work for Datadog.
And my name is Damien Matthieu, and I work for Elastic.
And I'm wondering, how many of you here have used profiling before? Okay, there's a whole bunch of people.
Nice.
How many of you are excited about profiling becoming something in OpenTelemetry, becoming an OpenTelemetry signal? Oh no.
Okay.
I think we have some bad news.
Yes, we have some bad news for you because we actually had an informal SIG meeting earlier, and we have made a very important decision. It's that we're going to drop profiling because logs are just enough.
Okay.
So, thank you.
So with this out of the way, let's get a little bit more serious. And let's start by defining what profiling is and why you might want to use it, and then talk a little bit about what we're doing in OpenTelemetry to support it there. So, yeah. While preparing this talk, I was trying to think of how to define profiling, and you can go to Wikipedia, and there's a bunch of stuff. You could say, is it the stack traces? Well, you could have those on traces as well for errors. Is it the data format? Well, logs could be actually used to store profiling data, and as we know, maybe they're going to replace profiling. And also, yeah, it's really not clear if the sampling is the thing, because you can sample traces as well. So there's a whole kind of ways to get in trouble with the definition. But so I decided to actually opt for this wise idea of, I might not be able to define profiling, but I know it when I see it. And so the typical thing that you will see the first time you encounter profiling is this visualization here, called the flame graph, invented by Brendan Craig. And what this visualization shows you is typically stack traces going from the bottom here to the top. So at the bottom, you've got the root frames, and going up, you go all the way to the leaf frames. And in this case, we're looking at a CPU profile. And each frame is basically showing you the width, is showing you how much CPU time is going into executing this function, as well as all the functions that it's calling. So it's cumulative. And you can use this visualization for CPU profiles, but you can also use it to break down memory usage, and you can use it to break down latency. But again, the main thing here is that even though it looks like some other visualizations you might have seen in distributed tracing, the x-axis is not actually the passage of time. There's no time ordering here. This is really an aggregated view of resource consumption in this case. But there's more to profiling than just the flame graph as a visualization. In particular, I think there's a lot of interesting visualizations that treat code execution over time as a first-class concern. I brought a few screenshots here from them tools. On the top left, you have Perfetto, and on the bottom left, you have the Datadog timeline. Both of these are thread visualizations that show you the execution of threads over time. And this can be very interesting if you have multi-threaded programs and you're trying to understand how many threads you have, how they're interacting with each other, how they're waking up each other, and where the bottlenecks are. And that's something that you can often not see in a single flame graph. But there's room for more visualizations. On the top right here, you have Google Chrome developer tools. And what they here have is a flame chart, where confusingly the x-axis actually is time, and the y-axis is still like sort of stack traces going up in time. But the way they make that work and meaningful is they have a very high sampling rate. So for example, in Chrome, when you use this, JavaScript does actually get sampled at a frequency of, I think, 10,000 times per second, which is very high frequency, and typically higher than what you see in multi-threaded programs, because you couldn't do that. JavaScript is single-threaded, so you get away with it. And another really interesting visualization here is Flamescope from Netflix, also from Brendan Craig, where the x-axis is time and the y-axis is millisecond offset. And there you can see interesting patterns of like hotspots of CPU usage and repeating occurrences of such CPU usage. So all of these visualizations have their place in time when you want to do profiling. And so why would you want to do profiling? Let's talk about a few example use cases. My favorite one is actually not performance, it's incidents. For example, at Datadog recently, we upgraded the base image and we saw CPU usage going up. And this is actually really hard to diagnose with any other tool than profiling, because in a base image upgrade, you're upgrading a lot of stuff. You're upgrading a lot of libraries, a lot of programs, a lot of things. And turning on profiling, we were immediately able to see that this was actually OpenSSL that had a regression, and that led us to immediately figure out what issue existed upstream, because now we had the keywords to Google for this issue. CPU increase was an upgrade from this version to that. So that made it really easy. And I think profiling is kind of the only tool that can help with stuff like this. But even more mundane stuff, let's say you roll out deploys, and you might be in an environment where you have a mono repo, there's hundreds of commits that actually go into a single deploy, you roll out a release, and suddenly you see a spike in CPU usage. You can roll back because you might be able to quickly pinpoint the release as like the cause of the regression, but then you still need to figure out which code change in your mono repo of hundreds of commits was actually responsible. And that's something where, again, profiling can show you the functions that are using more CPU time and quickly pinpoint the issue. Cost is another big good use case for profiling. When you're using too much CPU or too much memory, you usually want to bring the resource that you're using more of down, so they're about equal, because then you can scale down your whole infrastructure, and profiling lets you break down both CPU and memory usage to accomplish this. And last but not least, tail latencies. A lot of user experience these days is actually bound by tail latencies, because as a user does something on their device, hundreds of requests are fanning out in the backend of distributed systems. And if any of those requests is slow, the whole user experience is actually slow. So figuring out why your tail latencies are bad is a common activity to improve distributed system performance. And profiling can contribute to this, for example, by showing you that your tail latencies might be impacted by mutex contentions. And again, that's something that other tools make it very difficult to analyze. So because of the usefulness of profiling, slowly but surely, I think it has made its way to become the fourth pillar of observability. If you trace it back, I think Google's 2010 paper was maybe a starting point of this, where Google announced that they were actually deploying profiling at a large scale across all their data centers to understand what's going on there. And it took a little while for this idea to spread through the rest of the industry. But I would say around 2019, there was sort of the start of a Cambrian explosion of different companies offering continuous profiling as a tool. And unlike traditional profiling, where you might profile something in a development environment or in your local machine, all of these companies release tools that you can run alongside your production workload to understand any sort of incidents, performance, or other problems that you might have. But of course, as great as it is to have like 20, 30, 40 different vendors to choose from and to use in your stack, wouldn't it be nice if there was actually a single signal that you could use to get the data from any of those tools and make sure that in the future, as you switch between vendors, you can continue using it. And because of this, Damien, myself, and many others have been working on making profiling also the fourth signal of OpenTelemetry. And so the story there is that it goes back to 2020. There was a GitHub issue to propose profiling as a new signal type. And at the time, the OpenTelemetry community was a little busy with working on logs and metrics, so there was no bandwidth. But then in June 2022, that availability freed up, and we started to organize the first SIG meeting of people interested in profiling. It was very well attended. There were, I think, over 100 people who were interested in profiling becoming an OpenTelemetry signal. And this group has been gathering every 2 weeks since then and making steady progress towards making this vision happen. The first thing we shipped is in September 2022. We outlined the initial vision in an OTel number 212 that you can look up online. And then we followed this up with quite a delay to define the initial data model in February 2024 in OTel 239. The reason why it took quite a while is because it turns out OpenTelemetry is not the first standards body or first entity to try to create a profiling format. There's a website called Profilerpedia that you can check out, where there's, I think, 100+ different profiling formats listed. And so there was a lot of discussion around what OpenTelemetry profiling should look like based on that prior art. Maybe most interestingly, JFR and pprof were two formats being heavily discussed. But Elastic had also some very interesting idea of a stateful protocol. And so, yeah, there was a lot of discussions. But now we basically have a model that we all agreed to push forward and making good progress on it. In June 2024, another great development was Elastic donating an eBPF profiler that they had acquired from a company called Optimize and making this part of OpenTelemetry. And this was a big milestone because OpenTelemetry initially was just going to standardize the signal for profiling, but there wouldn't necessarily be any tools yet to produce profiling data. And it turns out you kind of need both to have a useful OpenTelemetry story. So this was really great. In August 2024, we also unlocked another big decision. The profiling format that is designed by this signal group right now is essentially still very similar to pprof. pprof because that ended up serving as the original inspiration. And the community asked a lot of questions like, does OpenTelemetry really need to create its own format? If it's so similar to pprof, maybe pprof should become part of OpenTelemetry. And so we had a lot of discussions with Google around this, and it was kind of holding up the progress on the signal. But finally, OpenTelemetry and Google, we all got together, and we realized that for Google's use cases, pprof is great as it is. There's no reason to change it. And for OpenTelemetry, we really want to have the flexibility to change the format for the needs of the OpenTelemetry community. And so the decision was made that pprof should stay the way it is. OpenTelemetry is breaking away from it, not trying to be fully compatible, but we are trying to make sure that pprof data can always be converted to OpenTelemetry data. So it will be convertible, but not one-to-one compatible. In October 2024, work continued, and the first version of OTLP support landed in the collector. And in January 2025, the eBPF profiler also became part of the collector as a OpenTelemetry receiver, which Damien is going to talk more about. And that's pretty much my part here. I just, at this point, also want to say thank you to all the companies who have donated their time and resources to contribute to the profiling signal and drive the signal towards stability. So thank you for that. All right, Damien, tell us more.
Yeah, thank you. So one of the things that we wanted to do when Elastic donated the eBPF profiler to OpenTelemetry is we did not want that to be its own standalone agent, and because OpenTelemetry already has a great framework for running things that can ingest and send data, that's the collector. So the goal was to be able to run the eBPF profiler as a collector. So it's the thing that Felix mentioned we shipped earlier this year. So we put profiles in the collector. The idea is to have this kind of way to configure your collector. So basically, you define a receiver in your collector for OTLP. And so you're going to be able to get OTLP data just like you would for metrics, logs, and traces, except this time it's for profiles, as we can see in this service at the end. So with that configuration, in a current collector released after 0.1120, so a recent one, you're going to be able to receive profiles data through OTLP. Obviously, you need something that is going to generate that data, because to get something, you need something to produce it. And that gives us the following architecture ID. So it's kind of ideal architecture. Obviously, you do not have to do the same thing exactly. It's really up to your need. But the idea is to have a central collector within your cluster, which is going to be the collector that is going to also receive other signals, like logs, metrics, and traces. It's probably the collector you already have in your cluster. And then you're going to have lightweight collectors that are going to be able to trigger, get profiling data. The reason is, since profiling is using eBPF, it needs to run as a daemon set, because it needs to run on every node. And you probably don't want to have a collector on every node that receives all signals, hence that profiling collector. The other reason is the main collector has a hard dependency or non-dependency of not using SIGO, whereas in the profiling collector, we do need SIGO for eBPF. So it's a bad idea to have both things the same way because of that condition. So that's the idea. Basically, you have each node using OTLP to generate the eBPF profiling data, using OTLP to send that data to a central collector, and then using OTLP or any other protocol of your choice to send the data to an external provider that is going to allow you to visualize the data. We start having lots of implementations in the collector, so things that are already done and available today. In terms of exporter, you can already export your data in file. Coralogic also has an exporter. Elasticsearch does too. You can receive data using OTLP JSON, though I'm not sure anything can send data using OTLP JSON, but you can receive it. And then you can also process your data in the middle using resource detection and K8 attributes. It's also a change from the original profiler that was donated, which is that original profiler has its own data, like metadata addition inside the agent itself. Now we are only generating profiles in the agent, and everything else is the responsibility of a framework collector. So if you need additional information on your profiles, you're going to be using the resource detection or K8 attributes detection, which is much more powerful because it means that we can reuse everything that the collector provides instead of having to build everything inside the same binary. And as a work in progress, I was kind of hoping that I could say today that it has been merged. It's not yet been merged, but it's a question of days, maybe just a couple of weeks. There will be OTel support, which will allow you to build queries to transform your data within the collector for profiles. So let's do a quick demo. By demo, I mean showing you some codes, quickly configuration code, and then playing a video because we are not crazy enough to play with the demo gods. So if you have this, I hope it's big enough. Here, I am going to run 2 collectors. One of them, which is configured here, which basically has an OTLP receiver. So it can receive OTLP data for profiles and has an exporter. So in this case, I'm exporting to Elasticsearch. So that's my cluster-wide collector, the one which is able to just receive OTLP data and then export it to be visualized. And my other collector is going to be this. So it has a receiver which is profiling. So it runs the eBPF profiler. So if you run your collector with eBPF profiler, the only thing you have to do to enable it is basically those first few lines here to configure it, and that's it. And I'm running the resource detection processor to add resource attributes such as host ID, host.name, to add more information to my profiles. And then I'm exporting that data to my OTLP collector that I started just before. So let's start our video. So I'm showing you, again, this configuration. I am, in a few seconds, going to start the process. Yes. So I'm starting the collector. And from now on, it can receive OTLP data for profiles. Then I'm going to do the same thing for the OTLP eBPF agent, which is then going to be emitting data, which is going through from my agent to the cluster-wide one. And then we are going to be able to view exactly like the generated data, our profiles, as they're generated in production this way. So the flame graph that Felix mentioned before that would allow us, in this case here, it's maybe too small, but we can actually see that we have profiling data for the running collector and everything that it does on the current site and everywhere. This is kind of showing the Elastic interface, sorry. But that's kind of showing you what basically you can do with just like the collector and how it works today. So what is next? Because as you can have guessed, maybe we're still in very much WIP state. And I would not necessarily recommend using that in production today. So what is required next is finalizing the OTLP protocol for profiling data. If you want to mention that, since it's more your thing.
So there's a few major things that we need to nail there. One is the representation of stack traces. We think that the current representation might not be ideal. We basically have encoded them as a long list of frames, and then you kind of get 2 pointers in them, cutting out a slice of stack frames. But we're revisiting this right now. And there's a lot of benchmarking being done to make sure we make a good decision there. Another one is the first-class consideration of timestamps. As I showed you earlier, the flame graph is one very useful way of looking at profiling data, but it's an aggregated view. Typically, you buffer up like a minute's worth of samples, and then you show them as a flame graph. But actually being able to see what all your threads are doing over time on CPU, maybe also off CPU, is very useful to support for an OTLP profiling signal. So we want to make sure that we have good support for that, and the current timestamp support in the protocol it needs a little bit more love. And last but not least, the resources. For a lot of people who interact with full host profiles from the eBPF profiler for the first time, they're a little overwhelmed by the fact that it's showing you everything on the host, and these days that often means it's a Kubernetes host running many different workloads, and a lot of times it's developers who are responsible for a single application, and they just want to focus in on their piece. And it might be their application, it might be their database, it might be their cloud-native component, sidecar, whatever, but they want to have a more focused view on that. And to nail that use case, we really need to get the resource tagging and the resource splitting working very well, and currently that still has some issues with how it's represented in the protocol, and the work needed to make that work actually is cross-collaboration with some of the other special interest groups. We also need to work on uploading OTLP protocol, or having a protocol for uploading symbol information. By default, an eBPF profiler collects stack traces as just numbers of program counters, so you just get a number for your stack frame, and that's not very useful. So for decoding those numbers into function names, file names, and line numbers, you need a protocol for uploading symbol information, which might not always be on the host. So OpenTelemetry needs to standardize that. We're working on a collector distribution that includes the eBPF profiler. I think that work is going really well.
Yes, so we have not restarted it, but basically right now the only way you can run the eBPF agent is by creating your own custom distribution. We want to make that easier by providing an official OpenTelemetry distribution that is going to be a lightweight collector, which is basically only going to be running the eBPF agent and exporting the data using OTLP with potential resource processors in the middle. And we also need to build better profiling correlations between trace and profiles, so that you can basically get a profiling information and go straight away to a trace that is linked to that profile data. And finally, I mentioned it earlier, but we are finalizing work on OTTL support, which is going to be a very powerful tool to transform your data live. So that's kind of it for the state of profiling at OpenTelemetry. As Felix mentioned earlier, the SIG is pretty active, but we always welcome more contributions if you feel like it is something that you could be helping us with. So feel free to join our CNC, our Slack channel, OTel Profiles, as well as our SIG meetings every 2 weeks. Feel free to come as an end user with your use cases. And to try out early versions and bring feedback to us so that we can know exactly what you need and how can things be better. I mentioned it before, but the profiling signal is not ready for production yet. So if you do that, do it at your own perils. But it's usable, at least, which is a great step compared to where we were, I guess, last KubeCon a year ago. Thank you very much. I don't think we have time for questions. Please give us feedback if you have any. And if you want to come talk to us after the talk, we'll be here for a few minutes. And we'll also be here at the observability booth, OpenTelemetry booth, on the coming days. Thank you very much.
Thank you.